Hi, hello, my dear students. Welcome back to our class. Very good morning to all. How are you? I am fine. Yesterday, we are discussing about the rate of change of velocity, that is acceleration, and its formula, and some numerical problem solving and daily life examples. We have to discuss, and the distance time graph and the velocity time graph also we are discussing yesterday. Now, I hope that all of you understand that topic. Now, we have to discussing today in motion lesson. The subtopics are equations of motion and uniform circular motion. Now, are you ready to listen? Very good. Now, we have to start the lesson today. Okay? Now, let us start. Here, today we are discussing about some equations of motions and some numerical problems solved, and the first law of motion, inertia, activity 1.8 inertia, and we have to discussing some real life examples. The first one is equations of motion. What is equations of motion? The equations are used to describe the motion of an object moving with a constant acceleration in a straight line. In these equations, we have to use some numerical, some letters and some numerical symbols also. Okay, we have to use the equations motions. The terms are used here is u, v, a, t, s. U means initial velocity. It measured meter per second, and v is final velocity. It is measured meter per second. A equal to acceleration. It measures meter per second square, and t is equal to time taken. It measures seconds, and s is equal to displacement. It measures meters. Okay. Now we have to discussing about the equations of motion. Here we have to see a car is moving on the road. Here a car is moving in a straight line. So, and u is equal to initial velocity is 0, and here t is equal to, that means time taken is equal to, in starting stage of the car, t is equal to 0 seconds, and after some time it moves some acceleration a, and some its velocity also changed, that is final velocity, that indicates v at time t. Okay, here the first equation, v is equal to u plus at. Here where v is equal to final velocity, u is equal to initial velocity, a is equal to acceleration, t is equal to time. It relates final velocity with initial velocity, acceleration and time. So final velocity is depending on initial velocity and acceleration and time also. Okay, that is v is equal to u plus at. This is the first equation of motion, and the second equation of motion is s is equal to ut plus of at square. Here s is equal to displacement, u is equal to initial velocity, a is equal to acceleration, t is equal to time. It relates displacement with initial velocity, acceleration and time. Here we have to find the displacement, then it depends on initial velocity, time taken and acceleration also. This is the second equation of motion, and the third equation of motion. Here v square is equal to u square plus 2s. Here final v is equal to final velocity, u is equal to initial velocity, a is equal to acceleration, s is equal to displacement. It relates final velocity with initial velocity, acceleration and displacement. Time not included. Here final velocity is depending on initial velocity, acceleration and displacement or distance. Okay, these are the three equations of motion. Here fourth equation also given. In this use of the first the distance or displacement, s is equal to u plus v by 2 into t. Here S is equal to displacement, U is equal to initial velocity, V is equal to final velocity, T is equal to time. It relates displacement with average velocity and time. So here we have to find the displacement. The formula is the average velocity into time. Okay, these are the equations of motions. Okay, here how to use these equations? Identify the known and unknown quantities and choose the equation that does not contain the unknown quantity. Substitute the values with correct units and calculate and write the answer with units. Okay, these are the how to use these equations in our daily in problem solving, and some real life examples are given here. Here, a car accelerates from 10 meter per second to 30 meter per second in 5 seconds. Find the acceleration. So, here we have to give initial velocity and final velocity and time. Now, we have to use the formula V is equal to U plus AT in the first equation of motion. Okay, here we have to substitute the initial velocity is 30 meter per second is equal the final velocity 30 meter per second is equal the initial velocity 10 meter per second plus a into t is 5. So we have to find the a. So we have to use this. Here we have to use and substitute the formulas in this equation. So 30 is equal to 10 plus 5a. So we have to find the acceleration a is equal to 30 minus 10 by 5, that equal to 20 by 5, that equal to 4 5 4 ja 4 meter per second square. That is the acceleration of the car. Okay, now we have to use this formula and find the acceleration of the car. And the second example is a ball is thrown upward with 20 meters per second and reaches a height of 15 meters. Find the time taken. Here we have to given the velocity of the ball. It is moving upward with 20 meters per second. So it reaches the height. So its initial velocity is 20 meters per second and it reaches the height of 15 meters. Okay, in the height of 15 meters its velocity is completely 0. So v is equal to here is 0. So only 20 meter per second is the u and its height, that means its distance or displacement is equal to 15 meters. So here given s is equal to 15 meters. Now we have to calculate the time taken. So we have to first you have to calculate the a using the formula of v is equal to u plus at. Then v is equal to 0 is equal to 20 plus a into t. Okay, here we have to substitute the values of given values in this equation and find the time taken here. Okay, and third example, a train slows down from 20 meter per second to 5 meter per second in 100 meters. Find the deceleration. Acceleration. Here the spelling mistake is there. That is a acceleration. Okay, a train slows down from 20 meter per second to 5 meter per second. So its initial velocity is 25 meter per second and final velocity is 5 meter per second. Okay, and in 100 meters, so s is given 100 meters and find the acceleration. Now a is find the a. So v, substitute v 25 meter per second is equal, e square is equal to 5 square plus 2 into a into s, that is 100. Now we have to calculate, we have to substitute the values in this equation and calculate the answer. Okay, these are all how to use these equations in daily life examples. Okay, here we have to learn what is learned in this topic. Once again we have to remember this. These equations are valid only when acceleration a is constant. Okay, the motion is along a straight line. You can use any equation that does not contain the unknown quantity you are trying to find. Okay, these are the key points. And also you have to remember all equations are valid only for constant acceleration in a straight line. Okay, these are the equations of motions. I hope that all of you understand this topic, equations of motion. Now we have to discussing about this, about the inertia activity 1.8 in our textbook. Now we have to learn what is inertia. Inertia is a property of a body by virtue of which it resists any change in its state of rest or uniform motion. Okay, inertia is the property of a body by virtue of which it resists any change in its state of rest or uniform motion. Okay, now we have to given the activity. Here we have our aim is to demonstrate inertia through simple activities. Here what we required materials are here is cardboard sheet, a coin, a glass, water, tablecloth or handkerchief, a table. Okay, these are the required materials. Now we have to done the activity. First activity is coin and card. Here what is the procedure is given here. Place a glass on the table. Place a cardboard on the mouth of the glass. Place a coin on the cardboard. Hit the cardboard sharply and quickly from one side. Observe what happens to the coin and the cardboard. The coin is in the glass. Okay. Next, second activity. Pull the cloth. Here spread a tablecloth on a table and place glass, a steel bowl or book on it. Okay, pull the cloth quickly one and smoothly from one side. Observe what happens to the objects. What happens? The cloth is moved but objects are at the same place on the table. Okay, here the first observation, the cardboard moves away but the coin falls straight into the glass as we shown in the figure. And in second activity, the cloth moves away but the objects remain in their original position as we shown in the figure. In first activity we have to understand what we understand is here. The coin was at rest. It tends to remain at rest due to inertia. When the cardboard is moved quickly, the coin does not get time to move and falls into the glass. Okay. In second case, the objects were at rest. They tend to remain at rest due to inertia. When the cloth is pulled quickly, the objects do not get time to move. Okay. These are the two activities given here. And here we have what we precaution we taken. Be careful while performing the activities. Do not spill water or break the glass. Okay, these are the we have to take the precaution here. Here we think and observe. Why do passengers jerk forward when a moving bus stops suddenly? And why does a book remains in place when we pull the tablecloth quickly? Here, when the bus stops suddenly, we are thrown forward because of inertia. And when a train starts suddenly, we are thrown backward. In this case, it is also called inertia. Dust comes out of a carpet when we beat it. In this time also, the inertia is happens. Okay, so what we learn in this topic inertia? All the above activities show that a body resists any change in its state or rest or uniform motion. This property of a body is called inertia. Okay, now what we learn in this lesson? Inertia keeps things in the state they are in rest or in motion unless an external force acts on them. Okay, these are the topic we have to discussing inertia. I hope that all of my dear students understand this topic inertia. Now we have to uh, do some examples in our textbook. Let us understand how the examples are solved step by step. Here the example 1.5. First I have to read and understand what data is given. Okay, now we have to solve this problem in which type equation of motion is used here. First example, a train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find first one is the acceleration and the second one is the distance traveled by the train for attaining this velocity. Okay, first given velocity, here we have to given the train starting from the rest, so initial velocity u is equal to 0. Okay, 0 meter per second. In final velocity v is equal to 72 kilometer per hour. It can be changed into meter per second, then its value is 20 meter per second. Then time is given, t is equal to 5 minutes and it can be changed into seconds. So 5 into 60, 300 seconds. So first one is find the acceleration. So we have to find the acceleration. We have to use v is equal to u plus at, the first law of motion, and it can be changed. We have to subject is a, then the formula is changed, a is equal to v minus u by t. Now stop substituting the values of u, v and t in this formula. So a is equal to v is equal to substitute 20, u substitute 0 and t substitute 300. So 20 minus 0 by 300, that equal to 1 by 15 meter per second square. So acceleration a is equal to 1 by 15 meter per second square. In second problem, the distance traveled by the train for attaining this velocity. So we have to, how much distance we have to traveled. The formula here used s is equal to ut plus of at square. Here we have to use the second law of motion, second equation of motion. So s is equal to ut plus of at square. So substituting values of u, a, t in this equation. So 0 into 300 plus half into 1 by 15 into 300 square, that equal to 1 by 30 into 90,000. Now we have to divide it by 90,000 into 3000. So 30, that equal to 3000 meters. So the distance traveled in the train is s is equal to 3000 meters. Okay, here we have to use these tips. What is this? Convert kilometer per hour to meter per second and use find the acceleration a is equal to v minus u by t formula, and we have to use the distance formula is s is equal to ut plus half at square. So this is the first problem. I hope that all of you understand this problem. And the second problem 1.6. A car accelerates uniformly from 18 km per hour to 54 km per hour in 6 seconds. Calculate the acceleration and the distance traveled in this time. Same questions. Now here given initial velocity u and final velocity v and time taken also. So u is equal to 18 meter per hour, sorry, 18 kilometer per hour. It can be changed into meter per second, that equal to 5 meter per second. And final velocity v is equal to 54 kilometer per hour, and it can it's change into meter per second, 15 meter per second, and t is equal to 6 seconds. Now find the acceleration. Use this above problem. We have which formula is used here, is also used that formula. So formula used, a is equal to v minus u by t. Now substituting values of given values. So a is equal to 15 minus 5 by 6, that equal 10 by 6, that equal 5 by 3 meter per second. So the acceleration is 5 by 3 meter per second square. And distance, second problem. We have to use the what formula used in first problem. Here you have to use that formula also. So s is equal to ut plus of at square. Now we have to substituting values of given data. So s is equal to 5 into 6 plus half into 5 by 3 into 6 square. So we have to find 5 6 are 30 plus 1 by 2 into 5 by 3 into 36. So 30 plus here 3 2 3 are 6, 6 6 are 36. 6 into 5 30. So 30 plus 30, that equals 60. So distance travelled is s is equal to 60 meters. Here we have to use also convert kilometer per hour to meter per second, and formula find the value of acceleration a is equal to v minus u by t, and find the distance formula s is equal to ut plus half at square. Okay, here we have to use the general methods for such problems is given here. Read the problem carefully and note what is given and what is to be found. Convert all quantities to SI units to meters, seconds, meter per second, etc. Identify the suitable formula for acceleration a is equal to v minus t, and for suppose for calculate the distance, use the formula s is equal to ut plus half at square. Substituting the values into the formula and calculate. Write the answer with the proper units. Okay, here we have to given the problems of, we have for find the acceleration, then you have to use a is equal to v minus u by t, and find the distance, we have to use s is equal to ut plus half at square. Here u is equal to initial velocity, v is equal to final velocity, a is equal to acceleration, t is equal to time, s is equal to distance. Now we have to remember uniform acceleration means the change in velocity is equal in equal intervals of time. Okay, that is the uniform acceleration. I hope that all of you understand this solving problems. Now we have to discussing about the uniform circular motion. Okay, this is the last topic of the motion lesson. Okay, now we in before we have to discussing about speed, velocity, acceleration, and uniform motion and non-uniform motion. Okay, and their formulas and their units and some solving problems, and we have to discussing about some daily life examples also. Now we have to discussing about the uniform circular motion. When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. The direction of motion changes continuously even though speed remains same. For example, an athlete running on a circular track, and a moon around the earth, satellite in orbit, ceiling fan moving. Okay, these are all the examples of uniform circular motion. Okay, here we have to give some closed circuits. Okay, that is rectangular track, hexagonal track, octagonal track, circular track. Here object changes its direction, not the speed. Okay, tracks can be different shapes: rectangular, hexagonal, octagonal, and circular. and circular path is the best example of uniform circular motion. Okay, these are the some examples of uniform circular motions. Here we have to use the formula for uniform circular motion is the circumstance of a circle of radius r is 2 pi r. So if an object takes t seconds to complete one round, then its speed is v is equal to speed, that is meter per second, r is equal to radius or circular path, that is in meters, that is called distance. Here we have to take the distance is r, and time to complete one round in taken in seconds. So we have to discussing the velocity is equal to distance by time. So here distance is 2 pi r and time is t. So now the speed of the velocity of circular motion object is 2 pi r by t. Okay, here the formula of circumstance, the velocity of the circular motion. Okay, here is also we have to give some textbook activity. Take a piece of thread and it's tie a small piece of stone at one end. Move more the stone to describe the circular path with constant speed by holding the thread at the other end as shown in the figure. Now let the stone go by releasing the thread. Can you tell the direction in which the stone moves after it is released? It is in circular path. Okay, by repeating the activity for a few times and releasing the stone at different positions of the circular path, check whether the direction in the which the stone moves remain the same or not. So here we have to move this thread thoroughly. It is moves and circular path. Okay, let do the activity. Tie a stone on the thread, move it in a circular with constant speed, release the stone. Observe the direction in which the stone moves. Here we have to observe the stone moves in a straight line along the target to the circular path. Okay, if no force acts on it, the stone continues to move in a straight line. This shows the change in direction causes change in motion. Okay, here we have to learn an object moving in a circular path has uniform speed, but its velocity is always changing. Okay, that means direction. Here we have to learn what we learn in this topic. Uniform circular motion is constant speed changing direction. The stone released moves in a straight line, that is tangent. Formula here we have to write the uniform circular motion v is equal to 2 pi r by t. Examples in daily life help us understand the concept better. Here we have to give some homework also. All of my dear children, write your notebooks and do it. Write the meaning of uniform circular motion. Draw the 4 tracks shown on page 3 by 4 and label them. Describe activity 1.11 in your own words. Give 3 real life examples of uniform circular motions. Okay, all of my dear children, are you noted? Okay. Now we have to discussing some more examples in uniform circular motion. Moon moving around the earth. This is the one example of uniform circular motion. And satellite in a circular orbit. Cyclist on a circular track. These are all examples of some more examples. Here we have to give some tip. Use a small stone and thread in class to perform activity 1.11 practically. Okay, all of you do this activity at your home. Okay, these are the uniform circular motion. I hope that all of my dear children understand this topic. Thanks to listen my lesson today. Today we have to complete the lesson motion. I hope that all of the topics in motion are understand, and you have to do some activities. It's your own in our home also. Thanks to watch my channel. Please like, share and subscribe my channel. This is used to some more people as you like to learn something about this class. Okay? I hope that all of you help to reach my video some more people. Okay? Thank you. Thanks to all. We are again meet in our next session. Thanks to all.